Atlantic Ocean, Part 1, Geographical Location and Boundaries. The Atlantic Ocean is the second largest ocean in the world, covering roughly 106 million square kilometers, which accounts for about 20% of the Earth's surface. Stretching from the Arctic Ocean in the north to the Southern Ocean in the south, the Atlantic lies between the Americas on the west and Europe and Africa on the east. It is not just a body of water, it is a vital part of the planet's climate system, ecological network, and human history. Geographical extent and boundaries. The Atlantic is bounded by specific landmasses and seas that define its expanse. Northern boundary. The Arctic Ocean connects to the Atlantic through channels like the Greenland Sea, Norwegian Sea, and the Labrador Sea. These northern waters are icy and cold, playing a crucial role in climate regulation and ocean currents. Southern boundary. The Southern Ocean marks the southern limit of the Atlantic near Cape Horn and the Antarctic region. This area is characterized by strong westerly winds and turbulent seas, which influence the movement of ocean currents globally. Western boundary. The coasts of North and South America form the western edges of the Atlantic. Notable features include the Gulf of Mexico, the Caribbean Sea, and extensive continental shelves that provide rich marine habitats. Eastern boundary. The western coasts of Europe and Africa mark the eastern boundary. This side of the Atlantic includes regions such as the Bay of Biscay, North Sea, and the waters off West Africa, which have historically been centers of trade and exploration. Subdivisions of the Atlantic Ocean. The Atlantic is conventionally divided into two main parts, the North Atlantic and the South Atlantic, separated approximately by the equator. North Atlantic. Home to important seas such as the Caribbean, Mediterranean, Baltic, and North Sea. The North Atlantic is generally warmer near the tropics and cooler as it approaches the Arctic. This region is also where some of the strongest storms and hurricanes develop, especially in the Caribbean and Gulf of Mexico. South Atlantic. Extends from the equator down to the Southern Ocean. The South Atlantic includes the South Georgia and South Sandwich Islands, areas known for rich marine life and cold water ecosystems. This part of the Atlantic experiences fewer tropical storms but is still influenced by powerful westerly winds and the Antarctic circumpolar current. Continental margins and ocean floor features. The Atlantic Ocean features a diverse continental margin, including shelves, slopes, and deep basins. Continental shelf. Shallow regions extending from the continents, often rich in fisheries and natural resources. These shelves vary in width. For example, the east coast of the United States has a relatively narrow shelf, while the West African coast has broader areas. Continental slope. Steep regions descending from the shelf into the deep ocean basins, often characterized by submarine canyons formed by erosion and sediment transport. Abyssal plains. Flat, deep regions making up most of the ocean floor, where sediment slowly accumulates over millions of years. Mid-ocean ridges. Including the Mid-Atlantic Ridge, a continuous underwater mountain range that splits the Atlantic roughly in half. This ridge is not just a physical feature, it is geologically active, influencing tectonic activity and seafloor formation. Coastal features and island chains. The Atlantic has numerous coastal formations, islands, and archipelagos that play ecological and economic roles. Caribbean islands. Includes nations and territories such as Cuba, Jamaica, Puerto Rico, and the Bahamas, famous for their biodiversity and tourism. Azores and Canary Islands. Volcanic islands in the eastern Atlantic that support unique ecosystems. Bermuda and Falkland Islands. Located in strategic positions, historically important for navigation and trade. Importance of geographical knowledge. Understanding the geography and boundaries of the Atlantic Ocean is crucial for navigation and shipping. Major shipping routes cross the Atlantic, connecting Europe, the Americas, and Africa, enabling global trade. Marine biodiversity management. The location of shelves, ridges, and currents affects fish populations and ecosystems, essential for conservation. Climate study. Knowledge of boundaries helps scientists model ocean-atmosphere interactions, crucial for predicting storms, temperature changes, and climate patterns. Historical exploration. From Christopher Columbus to modern explorers, the Atlantic's geography dictated voyages, colonization, and trade routes. The Atlantic Ocean is therefore not just a body of water but a dynamic, living system that connects continents, influences global climate, and sustains human civilization. Its geographical features, from the Arctic icefields to tropical islands, highlight its diversity and importance. Atlantic Ocean. Part 2. Size, Depth, and Climate. The Atlantic Ocean is the second largest ocean in the world, second only to the Pacific. It covers roughly 106 million square kilometers, accounting for about 20% of Earth's surface. Its vast expanse makes it a crucial player in global climate regulation, marine biodiversity, and human activity. Understanding the size, depth, and climate of the Atlantic is essential for scientists, navigators, and environmentalists alike. 1. Size of the Atlantic Ocean. Length. Approximately 8,000 kilometers from the Arctic Ocean in the north to the Southern Ocean near Antarctica. Width. Varies significantly. Narrowest point. About 2,800 kilometers between Brazil and Sierra Leone. Widest point. Approximately 4,830 kilometers between Newfoundland in Canada and Morocco. Surface area. Roughly 106 million square kilometers, making it about half the size of the Pacific. This immense size influences global weather patterns, ocean currents, and marine biodiversity. The Atlantic spans multiple climatic zones, from polar regions to tropical waters, creating varied ecosystems along its expanse. 2. Depth of the Atlantic Ocean. The Atlantic Ocean is deep and diverse, with areas ranging from shallow coastal shelves to extreme abyssal plains. Average depth. Around 3,646 meters, 11,962 feet. Deepest point. The Puerto Rico Trench, plunging to approximately 8,376 meters, 27,480 feet. This trench is one of the deepest points in the world's oceans and is located north of Puerto Rico. Continental shelves. Shallow regions extending from coastlines, often rich in fish stocks and marine resources. These shelves can extend hundreds of kilometers offshore, gradually sloping into the ocean's deeper zones. Continental slopes. Steeper areas beyond the shelves leading into abyssal plains, often cut by submarine canyons formed over millions of years by sediment transport and underwater erosion. Abyssal plains. Vast, flat regions that make up much of the ocean floor, covered with fine sediments and hosting unique ecosystems. Submarine features. Mid-Atlantic Ridge. An underwater mountain range that splits the Atlantic roughly in half, stretching 16,000 kilometers from the Arctic to the Southern Ocean. Seamounts and volcanoes. Active and extinct underwater volcanoes contribute to the ocean's geological diversity. Hydrothermal vents. Found along the Mid-Atlantic Ridge, these vents support unique species that thrive in high-pressure, high-temperature, mineral-rich environments. 3. Climate of the Atlantic Ocean. The Atlantic Ocean plays a critical role in global climate due to its vast size and dynamic currents. Its climate varies significantly across latitudes and regions. A. Polar climate. The North Atlantic near the Arctic is cold, often covered with sea ice during winter months. Icebergs carried by currents like the Labrador Current have historically posed hazards for shipping. Polar waters are rich in nutrients, supporting krill, fish, and marine mammals. B. Tropical climate. Equatorial and tropical Atlantic waters are warm, ranging from 25 to 30 degrees Celsius, 77 to 86 degrees Fahrenheit, at the surface. These warm waters fuel hurricanes and tropical storms, especially in the Caribbean Sea and Gulf of Mexico. Coral reefs, mangroves, and tropical fish thrive in these areas. C. Temperate climate. The North Atlantic Drift, a continuation of the Gulf Stream, carries warm water toward Europe, moderating winter temperatures in countries like England, France, and Spain. Seasonal storms occur, but temperatures remain relatively mild compared to other regions at the same latitude. D. Oceanic influence on global climate. The Atlantic participates in thermohaline circulation, or the global conveyor belt, transporting warm surface waters north and cold, dense water south. This circulation regulates ocean heat distribution, carbon storage, and climate patterns worldwide. Changes in Atlantic currents can affect weather, rainfall, and temperature across North and South America, Europe, and Africa. 4. Seasonal and regional variations. North Atlantic winter, strong storms and cold temperatures. Ice coverage expands in the northern regions. Summer, warmer waters, increased hurricane activity, and rich marine productivity. South Atlantic generally calmer than the North Atlantic, but affected by westerly winds and the Antarctic circumpolar current. Seasonal upwelling off West Africa and Brazil brings nutrient-rich waters, supporting fisheries and migratory species. Impact on marine life. Climate zones dictate species distribution, migration patterns, and reproduction cycles. Cold water species dominate the polar and temperate Atlantic, while tropical regions host coral reefs, mangroves, and diverse fish populations. 5. Human interaction and climate relevance. The size, depth, and climate of the Atlantic Ocean make it a central player in human economy and survival. Shipping and trade. Major routes connect Europe, the Americas, and Africa, taking advantage of currents like the Gulf Stream for faster navigation. Fisheries. Continental shelves and nutrient upwellings support commercial fishing industries. Climate monitoring. Scientists monitor Atlantic currents and temperatures to predict hurricanes, El Niño events, and climate changes. Summary. The Atlantic Ocean's enormous size, complex depth, and diverse climate make it one of the most important oceans on Earth. From the frozen Arctic waters to tropical Caribbean seas, the Atlantic supports diverse ecosystems, drives global weather patterns, and sustains human activity. Its physical characteristics form the foundation for understanding ocean currents, marine biodiversity, and environmental impact, which we will explore in the next parts of this script. Atlantic Ocean, Part 3, Mid-Atlantic Ridge and Geological Features. Stretching roughly 16,000 kilometers from the Arctic Ocean in the north to the Southern Ocean near Antarctica, it is a continuous underwater mountain range that divides the Atlantic roughly in half. Its existence is not just a topographical feature but a dynamic geological phenomenon that has shaped the ocean's floor and influenced global oceanography for millions of years. 1. Formation and tectonic significance. The Mid-Atlantic Ridge was formed by the divergence of tectonic plates, a process known as seafloor spreading. Tectonic plates. The Atlantic Ocean is located between the North and South American plates on the west and the Eurasian and African plates on the east. As these plates move away from each other at rates of 2 to 5 centimeters per year, magma rises from the Earth's mantle to create new oceanic crust. Seafloor spreading. This continuous creation of new crust pushes older crust away from the ridge, gradually widening the Atlantic Ocean over millions of years. The process has been ongoing since the breakup of the supercontinent Pangaea, around 200 million years ago. Geological impact. The ridge is a key site of volcanic activity and minor earthquakes. It also contributes to the formation of hydrothermal vents, underwater valleys, and ridges, which support unique ecosystems. 2. Physical characteristics. Height and structure. The Mid-Atlantic Ridge rises about 2,000 to 3,000 meters above the ocean floor in many places. Some peaks come close to the ocean surface but remain underwater. Valleys and rift zones. Along the ridge, central rift valleys indicate the sites where tectonic plates are actively pulling apart. These valleys are often 5 to 10 kilometers wide and can be several kilometers deep. Hydrothermal vents. These black smokers release mineral-rich, superheated water into the surrounding ocean. They are hotspots for life in an otherwise nutrient-scarce deep ocean. 3. Marine biodiversity. Around the ridge. The Mid-Atlantic Ridge is not just a geological marvel, it is also a biological hotspot. Hydrothermal vent communities. Species like giant tube worms, blind shrimp, and vent crabs thrive near hydrothermal vents. They rely on chemosynthesis rather than photosynthesis, converting chemicals from vent water into energy. Deep-sea fish and invertebrates. The ridge hosts unique fish species, squids, and cephalopods adapted to high pressure, low light, and cold temperatures. Coral ecosystems. Deep-sea corals attach to rocky outcrops along the ridge, providing shelter and food for countless species. These ecosystems are fragile and extremely specialized, making them vulnerable to deep-sea mining and climate change. 4. Volcanic activity and geological phenomena. Submarine volcanoes. Active and extinct volcanoes along the mid-Atlantic ridge create underwater mountains and islands, such as Iceland, which is one of the few places where the ridge rises above sea level. Earthquakes. The ridge experiences minor earthquakes as the tectonic plates shift and magma moves. While mostly small, these tremors indicate the dynamic nature of the ocean floor. Hydrothermal deposits. Minerals like sulfides, copper, and gold accumulate around vents, creating potential resources for future deep-sea mining, though with ecological risks. 5. Impact on oceanography. The mid-Atlantic ridge influences ocean currents, water mixing, and climate patterns. Barrier effect. The ridge acts as a physical barrier, influencing deep water currents and the movement of marine species. Nutrient upwelling. Seafloor topography forces cold, nutrient-rich water upward, supporting marine life even far from the sunlit surface. Thermohaline circulation. By affecting deep water flow, the ridge indirectly supports the global conveyor belt, essential for climate regulation. 6. Scientific exploration. The mid-Atlantic ridge has been a focus of oceanographic research for decades. Submersibles and remote vehicles. Scientists use ROVs, remotely operated vehicles, and manned submersibles to study vents, rocks, and marine life. Hydrothermal vent discoveries. In 1977, scientists discovered the first hydrothermal vents along the ridge, which revealed entire ecosystems independent of sunlight. Plate tectonics research. The ridge is a living laboratory for understanding plate movements, seafloor spreading, and volcanism. 7. Human relevance and economic potential. While deep and remote, the ridge has economic and strategic significance. Mineral resources. Hydrothermal vents and ridges contain metals like copper, zinc, gold, and rare earth elements. Navigation. Though mostly underwater, the ridge's topography can affect submarine navigation and deep-sea cables. Tourism and research stations. Iceland, near the ridge, benefits from geothermal energy and scientific tourism, highlighting the ridge's indirect economic impact. 8. Environmental concerns. The mid-Atlantic ridge, despite being remote, faces threats from human activity. Deep-sea mining. Extraction of minerals could destroy fragile hydrothermal vent ecosystems. Climate change. Altered ocean currents and temperature changes can affect vent chemistry and marine biodiversity. Pollution. Plastics and chemicals eventually sink to the deep sea, impacting species even at several kilometers below the surface. Conclusion. The mid-Atlantic ridge is more than an underwater mountain range, it is a geological and biological marvel. Stretching thousands of kilometers, it shapes the ocean floor, currents, and ecosystems. From hydrothermal vent communities to submarine volcanoes, the ridge is a testament to the dynamic forces of the Earth. It supports unique marine life, influences climate, and offers economic potential, while also reminding humans of the importance of ocean conservation. Understanding the mid-Atlantic ridge is essential for geologists, oceanographers, ecologists, and policymakers. Protecting its fragile ecosystems ensures that the Atlantic Ocean continues to sustain life, support commerce, and serve as a window into the Earth's geological history. Atlantic Ocean, Part 4, Major Ocean Currents. The Atlantic Ocean is a dynamic system of moving waters, with currents that circulate heat, nutrients, and marine life across the globe. These currents are not just physical phenomena, they are essential for regulating global climate, supporting biodiversity, and influencing human activity. The Atlantic hosts some of the world's most important currents, including the Gulf Stream, North Atlantic Drift, Canary Current, Brazil Current, and Labrador Current. Understanding these currents is crucial for oceanography, marine biology, and climate science. 1. The Gulf Stream. The Gulf Stream is perhaps the most famous Atlantic current, originating in the Gulf of Mexico and flowing along the eastern coast of the United States, before turning northeast across the North Atlantic. Characteristics. Warm water transport. The Gulf Stream carries tropical warm water to higher latitudes, moderating the climate of Western Europe. Countries like England, France, and Germany enjoy milder winters thanks to this heat transport. Speed and volume. Flowing at an average speed of 2 meters per second, it moves about 30 million cubic meters of water per second, a volume comparable to all rivers on Earth combined. Seasonal variation. The current is stronger in winter, when temperature differences between tropical and polar regions are highest, and weaker in summer. Ecological significance. The Gulf Stream transports nutrients, plankton, and marine species, creating productive fisheries along the eastern coasts of North America and the Caribbean. Migratory species like tuna, swordfish, and sea turtles rely on the current for movement between feeding and breeding grounds. 2. North Atlantic Drift. The North Atlantic Drift is a continuation of the Gulf Stream moving northeast toward Europe. Climate influence. This current warms northwestern Europe, making it temperate despite its high latitude. It stabilizes weather patterns, bringing mild winters and influencing storm systems over the Atlantic. Marine life impact. Warm water transport supports fish migration and plankton blooms, which are critical for fisheries in the North Sea and Norwegian Sea. Seasonal variations influence the distribution of cod, mackerel, and herring, which are sensitive to water temperature. 3. Canary Current. Flowing south along the northwest coast of Africa, the Canary Current is a cold, shallow current that carries water from the North Atlantic subtropical gyre. Key features. Brings cooler water to coastal regions, moderating the climate of West Africa. Causes upwelling, bringing nutrient-rich water to the surface, which supports dense fisheries. Ecological significance. Sardines, tuna, and anchovies thrive in the upwelling zones. Migratory birds and marine mammals often follow these nutrient-rich regions. 4. Brazil Current. The Brazil Current flows south along the eastern coast of South America, transporting warm tropical waters toward the South Atlantic. Ecological importance. Supports coastal biodiversity, including coral reefs, mangroves, and tropical fish. Interaction with the cold Malvinas, Falklands, current at around 30 degrees south latitude creates rich fishing grounds, vital for commercial fisheries. Climate influence. The warm Brazil current helps moderate coastal temperatures along eastern South America. It also influences rainfall patterns and storm development in the region. 5. Labrador Current. The Labrador Current is a cold current flowing south from the Arctic along the coast of Canada and Greenland. Key features. Carries icebergs from Greenland into the North Atlantic, historically causing hazards to navigation. Influences sea surface temperatures along eastern Canada and the northeastern United States. Ecological significance. Supports cold water species like cod, halibut, and shrimp. Its cold waters interact with warmer currents, creating productive fishing zones along the Grand Banks. 6. Thermohaline circulation, global conveyor belt. The Atlantic Ocean plays a central role in global thermohaline circulation, also known as the ocean conveyor belt. Mechanism. Driven by differences in water temperature and salinity, warm surface water flows north, cools, becomes denser, and sinks to form deep currents. This movement connects surface and deep waters across the globe, influencing climate and nutrient distribution. Global impact. Helps regulate Earth's climate by distributing heat. Affects carbon dioxide absorption, critical for mitigating greenhouse gas effects. Changes in this system can lead to climate disruptions, including altered rainfall, storms, and ocean temperatures. 7. Hurricanes and storm systems. The Atlantic currents are also integral to weather systems, particularly hurricanes. Tropical storms. Originate in the warm waters of the tropical Atlantic, primarily near the Caribbean and Gulf of Mexico. Energy source. Hurricanes derive energy from the heat transported by the Gulf Stream and tropical currents. Seasonality. Peak hurricane activity occurs from June to November, influenced by ocean temperature, wind patterns, and salinity. Economic and human impacts. Coastal communities rely on accurate forecasting of hurricane paths, which depends on understanding Atlantic currents. Fisheries and shipping routes are also affected by storm-driven changes in water movement. 8. Seasonal changes in currents. Currents like the Gulf Stream and North Atlantic Drift intensify in winter due to stronger temperature gradients. Summer sees weaker currents, but tropical regions experience increased hurricane activity. Seasonal variations influence migration, spawning, and productivity of marine species. 9. Interaction between currents. Warm and cold currents often meet, creating rich fishing grounds. For example, the Brazil Current and Falklands Current mix nutrients off South America. Interaction zones are also climate regulators, as they balance heat and salinity across latitudes. Currents serve as highways for marine species, guiding migrations of fish, turtles, and whales. 10. Human relevance of currents. Navigation and shipping. Major shipping lanes use currents like the Gulf Stream to reduce travel time. Fishing industries. Currents create nutrient-rich areas that sustain global fisheries. Climate research. Monitoring these currents helps scientists predict climate change effects, storm patterns, and ocean health. Conclusion. The Atlantic Ocean's currents are lifelines for the planet, regulating climate, supporting biodiversity, and facilitating human activities. From the powerful Gulf Stream to the cold Labrador Current, these moving waters influence temperature, weather, marine life, and global ocean circulation. Understanding their dynamics is essential for scientists, policymakers, and coastal communities worldwide. Atlantic Ocean, Part 5. Marine biodiversity and ecosystem. The Atlantic Ocean is not just a vast expanse of water, it is a vibrant, living system that hosts incredible biodiversity. From the polar ice fields in the north to the tropical coral reefs near the equator, the Atlantic supports a wide range of marine species, ecosystems, and habitats. Its biodiversity is shaped by ocean currents, temperature gradients, nutrient availability, and geological features. Understanding this richness is essential for conservation, fisheries management, and climate resilience. 1. Overview of Atlantic marine biodiversity. The Atlantic Ocean is home to an estimated 250,000 to 500,000 marine species, though many remain undiscovered, especially in the deep ocean. Species range from microscopic plankton to giant whales, forming a complex food web. Plankton. The base of the food chain. Plankton includes phytoplankton, photosynthetic algae, and zooplankton, tiny animals. They convert sunlight into energy, support fish populations, and regulate carbon dioxide in the atmosphere. Invertebrates. The Atlantic hosts crustaceans, mollusks, and jellyfish. Crabs, lobsters, shrimps, and squids are not only ecologically important but also economically valuable. Fish. Thousands of species inhabit the Atlantic, including cod, tuna, mackerel, swordfish, and herring. Fish diversity varies with latitude, depth, and habitat type. Marine mammals, dolphins, whales, seals, and manatees are found across the Atlantic. These species are keystone predators and indicators of ocean health. Reptiles and birds. Sea turtles like the leatherback and loggerhead migrate across the Atlantic. Seabirds, including albatrosses and gulls, depend on the ocean for feeding. 2. Major marine ecosystems. A. Coral reefs found mainly in tropical Atlantic regions, such as the Caribbean and Brazilian coast. Reefs are home to thousands of fish, invertebrates, and algae species. Coral reefs protect coastlines from erosion, support tourism, and sustain fisheries. B. Mangroves and estuaries. Mangrove forests along the Atlantic coasts of South America, West Africa, and the Caribbean provide nursery grounds for fish and habitat for birds and crustaceans. Estuaries, where rivers meet the ocean, are nutrient-rich zones that support species like shrimp, crabs, and juvenile fish. C. Open ocean, pelagic zone. This vast zone is home to large migratory species like tuna, marlin, and whales. Predators like sharks maintain balance in the food chain. Plankton blooms in the pelagic zone create highly productive feeding areas. Deep sea and abyssal zones below 2,000 meters, the Atlantic hosts hydrothermal vents, seamounts, and abyssal plains. Unique species like tube worms, giant squids, and bioluminescent fish thrive in extreme conditions. These ecosystems are fragile, largely unexplored, and provide insights into evolution and adaptation. 3. Factors influencing biodiversity. Temperature. Warm tropical waters support coral reefs and tropical fish, while cold polar waters host krill, cod, and seals. Salinity. Variations in salinity influence species distribution and reproduction cycles. Ocean currents. Currents like the Gulf Stream transport nutrients and larvae, connecting distant ecosystems. Geological features. The mid-Atlantic ridge, submarine volcanoes, and trenches provide habitats for deep-sea organisms. Nutrient availability. Upwelling zones, particularly along West Africa and Brazil, support rich fisheries due to nutrient influx. 4. Keystone species in ecosystem roles. Plankton form the foundation of the food web, supporting fish, birds, and marine mammals. Sharks and predators control populations of smaller species, maintaining ecological balance. Coral and mangroves provide habitats, protect coasts, and support biodiversity. Whales influence nutrient cycling through waste, supporting phytoplankton growth. 5. Human interaction with marine biodiversity. Fisheries. The Atlantic supports global fisheries, providing food and employment. Tourism. Coral reefs, islands, and marine mammals attract millions of tourists annually. Shipping. Routes intersect biodiversity hotspots, requiring environmental management to prevent species disruption. Research. Scientists study species, ecosystems, and genetic diversity to understand climate impact, evolution, and conservation needs. 6. Threats to biodiversity. Overfishing. Commercial exploitation of cod, tuna, and shrimp threatens population stability. Pollution. Plastics, oil spills, and chemicals harm marine life across all zones. Climate change. Rising sea temperatures lead to coral bleaching, altered migration patterns, and species extinction. Habitat destruction. Coastal development, dredging, and mining destroy mangroves, reefs, and estuaries. 7. Conservation efforts. Marine protected areas, MPAs, established in regions like the Caribbean and Azores to preserve habitats. Sustainable fisheries. Quotas, seasonal bans, and fishing regulations aim to prevent overexploitation. Climate action. International efforts to reduce greenhouse gas emissions indirectly protect marine biodiversity. Research and awareness. Organizations monitor species health, migration, and ecosystem changes to inform policy. 8. Biodiversity hotspots. Caribbean Sea, coral reefs, tropical fish, and mangroves. Bermuda Triangle region. Pelagic ecosystems with migratory species. West African upwelling. Sardines, tuna, and seabirds thrive here. Brazilian coast. Coral reefs, mangroves, and sea turtles. North Atlantic. Cod, herring, whales, and deep-sea communities. 9. Ecological interactions. Predator-prey relationships maintain population balance. Symbiosis occurs in coral reefs, fish-cleaning parasites, algae photosynthesis, and hydrothermal vents, tube worms, and bacteria. Nutrient cycling supports plankton growth, which fuels the entire marine food web. 10. Summary. The Atlantic Ocean is a living, breathing ecosystem, rich in biodiversity from polar to tropical regions. Its species interact in complex food webs, influenced by currents, climate, and geological features. While humans rely on the Atlantic for food, commerce, and recreation, it faces threats from overfishing, pollution, and climate change. Conserving its ecosystems ensures sustainable resources, stable climate, and thriving marine life. The Atlantic's marine biodiversity is a treasure of life, vital for both the planet and humanity. Atlantic Ocean, Part 6. Economic importance. The Atlantic Ocean has played a crucial role in human civilization and the global economy for centuries. Its vast waters, abundant marine life, and strategic locations make it indispensable for trade, fisheries, tourism, energy, and mineral extraction. Understanding the economic importance of the Atlantic Ocean helps highlight why it must be protected and sustainably managed for future generations. 1. Ports and shipping. The Atlantic Ocean hosts some of the world's busiest ports, serving as gateways for international trade. Major ports: Rotterdam, Netherlands, one of the largest in Europe, handling millions of containers annually. New York and New Jersey, USA, vital for transatlantic trade and shipping industries. Hamburg, Germany, a key hub for European imports and exports. Santos, Brazil, South America's busiest port, facilitating export of agricultural goods. Cape Town, South Africa, an important port connecting Atlantic and Indian Ocean trade routes. Economic impact. The Atlantic supports billions of dollars in international trade annually. Shipping lanes along the Atlantic connect Europe, the Americas, and Africa, reducing transportation costs and delivery time. Ports generate employment for millions in logistics, warehousing, shipping, and customs operations. 2. Fishing zones. The Atlantic Ocean is one of the richest fishing grounds in the world, supporting both commercial and subsistence fisheries. North Atlantic, famous for cod, herring, mackerel, and haddock. Areas like the Grand Banks off Canada are historically significant for fisheries. Caribbean and tropical Atlantic supports tuna, snapper, and shrimp. Mangrove ecosystems serve as nurseries for juvenile fish, ensuring sustainable populations. South Atlantic, rich in sardines, anchovies, and deep-water species along the Brazilian and West African coasts. Economic significance. Fisheries contribute to food security, providing protein for millions. Commercial fishing is a multi-billion-dollar industry, creating jobs in catching, processing, and export. Sustainable fisheries management ensures long-term economic stability and ecological balance. 3. Mineral resources. The Atlantic Ocean floor contains valuable mineral deposits, making it an important site for potential extraction. Manganese nodules, found in the abyssal plains, rich in manganese, nickel, copper, and cobalt. Hydrothermal vents, deposits of sulfide minerals that include gold, silver, and rare earth elements. Sand and gravel, extracted for construction and coastal development along Atlantic shores. Economic potential. Deep-sea mining could provide strategic minerals essential for technology, renewable energy, and electronics. Coastal countries can benefit from exclusive economic zones, EEZs, securing rights to resources. However, extraction must be carefully managed to avoid ecosystem destruction and biodiversity loss. 4. Energy resources. The Atlantic Ocean supports multiple energy sectors, including fossil fuels and renewable energy, oil and gas. Offshore reserves exist along Brazil, West Africa, and the Gulf of Mexico. Deepwater drilling supports national energy needs and contributes to global energy supply. Renewable energy. Wind farms off the coasts of Europe and the United States are expanding rapidly. Tidal and wave energy projects are being explored to harness sustainable energy. Economic impact. Energy extraction creates jobs in engineering, operations, and maintenance. Renewable energy projects reduce carbon footprint and contribute to sustainable development. Strategic energy resources along the Atlantic influence geopolitical and economic stability. 5. Tourism and recreation. The Atlantic Ocean attracts millions of tourists annually. Beaches and islands. Caribbean islands, Azores, Canary Islands, and Brazilian coasts are famous for beaches, resorts, and marine activities. Water sports. Activities like scuba diving, snorkeling, sailing, and surfing are economically significant. Ecotourism. Whale watching, coral reef exploration, and deep-sea expeditions attract eco-conscious travelers. Economic significance. Tourism supports local economies, small businesses, and service sectors. Creates employment opportunities in hospitality, transport, and recreation. Promotes conservation awareness, linking economic benefits with environmental protection. 6. Trade and commerce. The Atlantic Ocean is a primary corridor for global commerce, connecting continents. North America left right arrow, Europe, South America left right arrow, Africa, Caribbean left right arrow, Europe and North America. Major exports transported via Atlantic shipping include oil, agricultural products, manufactured goods, and raw minerals. Economic dependence on Atlantic trade routes ensures international cooperation and infrastructure investment. 7. Strategic importance. The Atlantic Ocean is critical for naval defense and geopolitics. Control over Atlantic shipping lanes influences global trade security. Countries bordering the Atlantic have historically established colonies, trade posts, and naval bases, highlighting its strategic role. 8. Environmental and economic balance. While the Atlantic Ocean provides enormous economic benefits, unsustainable exploitation can lead to overfishing. Collapsing fisheries threaten livelihoods and food security. Pollution. Oil spills and marine litter damage ecosystems and reduce tourism and fisheries productivity. Climate change impact. Rising sea levels, storms, and warming waters affect ports, shipping, and coastal infrastructure. Sustainable management ensures long-term economic prosperity while protecting the ocean's natural wealth. 9. International economic cooperation. Countries bordering the Atlantic collaborate through treaties and organizations. International Maritime Organization, IMO, regulates shipping and safety. Regional Fisheries Management Organizations, RFMOs, monitor and manage fish stocks. United Nations Convention on the Law of the Sea, UNCLOS, defines rights over mineral and resource exploitation. Importance. Cooperation ensures equitable resource sharing, conflict reduction, and protection of marine biodiversity. Encourages research, monitoring, and sustainable development across the Atlantic region. 10. Summary. The Atlantic Ocean is an economic powerhouse, supporting trade and shipping, connecting continents and generating billions in commerce. Fisheries, feeding millions and sustaining livelihoods. Mineral and energy resources, from oil, gas, and manganese to potential deep-sea mining. Tourism and recreation, driving local economies and global travel industries. Strategic and geopolitical importance, shaping defense, trade security, and international relations. Sustainable management of these economic resources ensures that the Atlantic continues to provide wealth, food security, and energy, while maintaining the health of its ecosystems. By balancing economic development with environmental protection, nations can harness the full potential of the Atlantic Ocean for generations to come. Atlantic Ocean, Part 7, History and Exploration. The Atlantic Ocean has been a central stage for human exploration, trade, and colonization for centuries. Its vast expanse connected continents, enabling the exchange of goods, ideas, and cultures, and profoundly shaping world history. Understanding the history of the Atlantic provides insights into maritime innovation, economic development, and cultural transformation. 1. Early human knowledge of the Atlantic. Ancient civilizations such as the Phoenicians, Carthaginians, and Greeks were aware of the Atlantic's existence. Seafaring knowledge was limited to coastal navigation and short voyages. Early myths and maps often depicted the Atlantic as a mysterious and dangerous ocean, inhabited by monsters and unknown lands. Despite uncertainty, Atlantic exploration influenced trade in tin, metals, and other resources in ancient Europe and Africa. 2. Age of Discovery, 15th–17th century. The Age of Discovery marked the beginning of systematic exploration of the Atlantic. Key explorers. Christopher Columbus, 1492, reached the Caribbean, initiating European colonization. John Cabot, 1497, explored North American coasts under England's commission. Ferdinand Magellan, 1519–1522, although famous for circumnavigation, his voyage mapped parts of the Atlantic and its connections to other oceans. Motivations for exploration included trade, desire for spices, gold, and precious metals. Territorial expansion. European powers sought colonies in the Americas. Religious mission. Spreading Christianity influenced expeditions. Impact. The Atlantic became the gateway to the New World, establishing new trade routes. Indigenous populations faced displacement, cultural change, and disease. European powers claimed vast territories, shaping modern geopolitics. 3. The transatlantic trade and colonization. The Atlantic Ocean facilitated the triangular trade between Europe, Africa, and the Americas. Europe right-pointing arrow Africa. Manufactured goods and weapons. Africa right-pointing arrow Americas. Enslaved people transported under brutal conditions. America's right-pointing arrow Europe. Sugar, tobacco, cotton, and other commodities. Colonization led to the establishment of plantations, ports, and settlements along the Atlantic coasts. Economic and social impacts. Wealth generated from Atlantic trade fueled European economic growth. African societies were disrupted by slavery and forced migration. Indigenous cultures in the Americas were profoundly affected, with loss of land, population, and sovereignty. 4. Maritime innovation. Exploration of the Atlantic required advances in navigation and shipbuilding. Caravels. Small, maneuverable ships capable of long voyages. Astrolabe and compass. Allowed sailors to determine latitude and direction accurately. Mapmaking. Early atlases and charts improved maritime safety and route planning. Long-term effects. Innovations enabled faster voyages, safer crossings, and expanded trade. European powers gained strategic advantages over rivals in colonial expansion. 5. Scientific exploration. By the 18th and 19th centuries, the Atlantic became a laboratory for oceanography, biology, and meteorology. Notable explorations. Charles Darwin's voyage on HMS Beagle, 1831 to 1836, observations of Atlantic islands and coastlines contributed to the theory of evolution. Oceanographic surveys. Mapping of currents, depths, and marine life improved navigation and understanding of ecosystems. Contribution to knowledge. Atlantic exploration expanded understanding of marine biodiversity, geology, and climate patterns. Scientific voyages laid the foundation for modern oceanography. 6. Naval conflicts and strategic control over the Atlantic influenced European power struggles from the 16th century onward. Spanish Armada, 1588. England resisted Spanish attempts to dominate Atlantic trade. 7 Years' War, 1756 to 1763. Naval battles secured trade routes and colonies. World Wars. The Atlantic was a crucial theater for submarine warfare, convoy protection, and strategic supply lines. Economic and political importance. Dominance over Atlantic routes allowed nations to control global trade, military influence, and colonial territories. Naval advancements directly impacted economic prosperity and national security. 7. Trade routes and economic development. Atlantic trade routes facilitated the flow of commodities, raw materials, and manufactured goods. North Atlantic route linked Europe and North America, vital for shipping and commerce. South Atlantic route connected Europe, Africa, and South America, supporting triangular trade and colonization. Caribbean Passage provided access to tropical resources such as sugar, coffee, and spices. Legacy. These routes established global economic networks, shaping modern international trade. Ports and cities along the Atlantic coast prospered as commercial hubs, many of which remain economically important today. 8. Cultural exchange and migration. The Atlantic Ocean facilitated exchange of cultures, languages, and traditions. African music, cuisine, and religious practices influenced the Caribbean and Americas. European languages, legal systems, and architectural styles spread across colonies. Migration waves shaped demographics and social structures, particularly in the Americas. Long-term impacts. Atlantic exploration created a globally interconnected world. Cultures along the Atlantic coasts are diverse and blended, reflecting centuries of maritime history. 9. Modern exploration and research today. The Atlantic continues to be a focus of scientific research and maritime innovation. Submersibles and ROVs explore deep-sea ecosystems, hydrothermal vents, and oceanic trenches. Climate monitoring. Currents, sea surface temperatures, and salinity are tracked to understand global warming and climate change. Biodiversity studies. Research on Atlantic species informs conservation and sustainable fisheries. Importance. Modern exploration combines science, technology, and environmental stewardship. Atlantic research helps predict natural disasters, protect ecosystems, and plan sustainable economic activities. 10. Summary. The Atlantic Ocean has shaped human history, commerce, and science. From early seafarers to modern researchers, it has been a pathway for exploration, trade, and cultural exchange. Its waters facilitated the age of discovery, colonial expansion, transatlantic trade, and scientific breakthroughs. The legacy of Atlantic exploration underscores the interconnectedness of nations, the importance of maritime knowledge, and the need for sustainable management of its resources. Understanding this history is essential for appreciating the Atlantic's role in shaping our modern world. Atlantic Ocean, Part 8, Environmental Challenges and Climate Change Impact. The Atlantic Ocean, despite its vastness and importance, faces numerous environmental challenges that threaten its ecosystems, biodiversity, and the livelihoods of millions who depend on it. Climate change, pollution, overfishing, and habitat destruction are some of the major issues affecting the Atlantic. Understanding these challenges is crucial for sustainable management, conservation, and long-term ecological balance. 1. Climate change and ocean warming. Global warming has led to a rise in sea surface temperatures across the Atlantic. Warming waters affect ocean currents like the Gulf Stream, which in turn influences weather patterns, rainfall, and storm formation in surrounding regions. Increased temperatures threaten marine species, especially those adapted to specific temperature ranges, such as coral reefs in the Caribbean. Impacts on biodiversity. Coral bleaching. Warmer waters cause corals to expel symbiotic algae, resulting in bleaching and reduced reef health. Altered migration patterns. Fish, whales, and seabirds shift their feeding and breeding areas in response to temperature changes. Invasive species. Warmer waters facilitate the spread of non-native species, which can outcompete native organisms. 2. Ocean acidification. Increased carbon dioxide, CO2, in the atmosphere dissolves in seawater, lowering the ocean's pH levels. Acidification affects calcifying organisms, including corals, shellfish, and plankton, which are essential to the food chain. Impacts on plankton disrupt nutrient cycles, threatening larger species like fish and whales. Economic consequences. Fisheries and aquaculture face declining yields and productivity. Coral reef degradation affects tourism and coastal protection, reducing economic revenue. 3. Overfishing and unsustainable practices. Intensive fishing in the Atlantic has led to overexploitation of key species such as cod, tuna, and shrimp. Techniques like bottom trawling destroy seabed habitats, while bycatch kills non-target species including turtles, dolphins, and seabirds. Long-term effects. Population collapses reduce biodiversity and ecosystem stability. Coastal communities dependent on fisheries face economic hardship. Disrupted food webs impact marine predators and global fisheries markets. 4. Pollution and marine debris. The Atlantic suffers from multiple types of pollution. Plastic waste. Millions of tons of plastic accumulate in gyres, affecting seabirds, turtles, and fish. Oil spills. Major spills from shipping or offshore drilling contaminate water and shorelines. Chemical runoff. Pesticides, heavy metals, and industrial waste enter coastal and pelagic zones. Impacts. Wildlife ingests or becomes entangled in debris, causing injury or death. Coastal tourism and fishing industries are economically affected. Ecosystem health deteriorates, threatening long-term ocean resilience. 5. Habitat destruction. Coastal development, dredging, and mining destroy vital habitats such as mangroves, estuaries, and seagrass beds. Mangroves, which serve as nursery grounds for fish and protection against storms, are being cleared for urbanization and aquaculture. Coral reefs, already stressed by climate change, face additional damage from boat anchoring, tourism, and sedimentation. Consequences: loss of biodiversity and fisheries productivity. Reduced natural protection against coastal erosion and extreme weather events. Altered carbon storage capacity, impacting climate regulation. 6. Rising sea levels. Melting polar ice caps and thermal expansion of seawater are causing sea levels to rise. Low-lying Atlantic islands, coastal cities, and delta regions face flooding, land loss, and saltwater intrusion. Critical infrastructure such as ports, tourism resorts, and residential areas are at risk. Economic and social impacts. Displacement of coastal communities. Loss of agricultural land due to saltwater contamination. Increased costs for infrastructure adaptation and disaster management. 7. Extreme weather events. The Atlantic Ocean is a hotspot for hurricanes, tropical storms, and cyclones. Rising sea temperatures intensify the frequency and intensity of these storms. Coastal regions face destruction of property, economic loss, and human casualties. Mitigation and adaptation. Improved storm forecasting and early warning systems. Development of resilient infrastructure and coastal defense mechanisms. Ecosystem-based approaches like restoring mangroves and reefs to absorb storm impact. 8. Marine protected areas and conservation efforts. Countries bordering the Atlantic have established marine protected areas, MPAs, to safeguard ecosystems. Examples include Sargasso Sea, protects unique open ocean habitats. Azores Marine Reserve, conserves deep-sea ecosystems and migratory species. Caribbean MPAs, focus on coral reef preservation and sustainable fisheries. Goals: preserve biodiversity and ecosystem services. Support sustainable fisheries and tourism. Promote research and environmental education. 9. Research and international cooperation. Organizations like the United Nations, NOAA, and regional fisheries bodies monitor and regulate Atlantic resources. Studies focus on climate change impact, species migration, and ecosystem health. Collaboration ensures sustainable management, pollution reduction, and adaptation strategies. Significance: research informs policymaking, conservation strategies, and sustainable economic planning. International cooperation reduces conflicts over resources and promotes shared stewardship of the Atlantic Ocean. 10. Summary. The Atlantic Ocean faces serious environmental challenges driven by climate change, pollution, overfishing, habitat destruction, and rising sea levels. These challenges affect biodiversity, ecosystems, human communities, and global economic activities. Addressing them requires sustainable fisheries and resource management, pollution control and waste reduction, habitat protection and restoration, climate adaptation strategies, and resilient infrastructure, international cooperation for research and conservation. By taking these actions, nations can ensure the Atlantic Ocean continues to provide ecological, economic, and cultural benefits for current and future generations. The Atlantic's health is directly linked to global well-being, making its preservation a shared responsibility. Atlantic Ocean, Part 9, Famous Locations, Islands, and Notable Features. The Atlantic Ocean is home to a vast array of islands, unique coastal regions, and notable oceanic features that have fascinated explorers, scientists, and travelers for centuries. From tropical paradises to dramatic underwater structures, these locations not only contribute to biodiversity and tourism but also hold historical, cultural, and ecological significance. Exploring the Atlantic's famous locations reveals the ocean's diverse beauty, geological wonders, and global importance. 1. The Caribbean Islands. Overview. The Caribbean is a cluster of over 7,000 islands, islets, reefs, and cays, stretching from the southeastern Gulf of Mexico to the northeastern coast of South America. Notable islands: Bahamas, known for crystal-clear waters, coral reefs, and luxury tourism. Jamaica, famous for its culture, music, and rich marine biodiversity. Barbados, St. Lucia, Antigua, and Grenada offer stunning beaches, rainforests, and diverse ecosystems. Significance. Economically, tourism drives local economies, creating employment in hospitality, transport, and recreation. Ecologically, coral reefs, mangroves, and seagrass beds support fish populations and coastal protection. Historically, Caribbean islands were central to colonial trade, slavery, and cultural exchange. 2. Azores Archipelago, located in the mid-North Atlantic, Portugal's Azores consist of 9 volcanic islands. Famous for volcanic landscapes, crater lakes, geothermal springs, and rich marine life. Whales and dolphins are frequently observed, making it a prime ecotourism destination. Importance. Scientific research focuses on volcanology, oceanography, and biodiversity. Tourism and fisheries are main economic drivers, highlighting sustainable use of natural resources. 3. Canary Islands, Spanish territory off the northwest coast of Africa, consisting of 7 main islands. Notable features include Teide volcano in Tenerife, unique desert-like landscapes, and black sand beaches. The islands are also recognized for astronomical observatories, due to clear skies and minimal light pollution. Cultural and economic value. Tourism attracts millions of visitors annually. The islands serve as stopovers for transatlantic voyages and trade routes. Rich marine ecosystems support fisheries and conservation projects. 9. International collaboration and policies. The Atlantic Ocean is shared by numerous nations, requiring cooperative research and management. Organizations like UNESCO's Intergovernmental Oceanographic Commission, IOC, North Atlantic Marine Science Organization, ICES, regional fisheries management bodies promote research, data sharing, and sustainable practices. Goals: protect biodiversity, manage fisheries, and ensure safe maritime navigation. Monitor climate change, pollution, and habitat degradation. Develop global policies for sustainable ocean governance. 10. Summary. Scientific research and oceanography in the Atlantic Ocean are vital for understanding climate systems, marine biodiversity, geological processes, and human impact. The ocean serves as a living laboratory for mapping seafloor and geological structures, monitoring currents, climate, and weather, studying biodiversity, migration, and deep-sea ecosystems, investigating pollution, environmental stressors, and human impact. International cooperation, technological advancements, and sustainable management ensure the Atlantic continues to support life, commerce, and scientific discovery. Protecting and studying the Atlantic is essential not only for current ecological and economic stability but also for future generations to benefit from its resources, knowledge, and beauty. Thank you for joining us on this deep dive into the Atlantic Ocean. Wave. From its fascinating history and breathtaking islands to the incredible marine life and scientific discoveries, the Atlantic truly is a world of wonder. If you enjoyed this journey, don't forget to hit the like button, thumbs up, subscribe to our channel for more amazing explorations, and click the bell icon so you never miss an adventure. Share your thoughts in the comments below. Which Atlantic feature amazed you the most? And remember, every part of our oceans is worth exploring and protecting. Stay curious, stay inspired, and we'll see you in the next video.